Now let's do a couple examples where we're going to end up dividing by a negative so we can remember exactly how to handle that situation. So first let's work on trying to get that absolute value isolated. We're going to subtract 7 from both sides, so this will become negative 2 times the absolute value of 3x plus 5 is less than or equal to negative 20. And now we're going to divide both sides of this equation by the value that's next to the absolute value, in this case negative 2. So when we divide both sides by negative 2, we have to remember the direction of the inequality changes. So negative 20 divided by negative 2 would become positive 10, but with the direction of the inequality switched. See how it switched from this step to this one? Now we're ready to turn to our rule for interpreting absolute values greater than a number. So this means that 3x plus 5 is less than or equal to negative 10, or 3x plus 5 is greater than or equal to positive 10. And now we solve each of these inequalities. So subtracting 5, we get 3x is less than or equal to negative 15. Divide by 3, x is less than or equal to negative 5. Or, solving the other side, when we subtract 5, we get 3x is greater than or equal to 5. Divide by 3, x is greater than or equal to 5/3. So putting this together, we want, we want all values that are less than negative 5. So that's going to be things from negative infinity up to negative 5. And since it's less than or equal to, we're including 5. Over here for this interval, we want all values bigger than this fraction. So that's going to be 5/3 up to infinity. And we're including this because x can be greater than or equal to 5/3. So square bracket. And then we're going to put a union in between because it's both of these intervals together. Note if we start with what is almost the same problem, but all we do is switch the direction of the inequality, we get a very different solution set. So in this case, we're going to start off the same way. So subtract 7 from both sides. So we get negative 20 on the right, just like we did before. Now we're going to divide by negative 2, giving us a positive 10 on the right again, except still we have to switch the direction of the inequality so it becomes a less than or equal to positive 10. Now that we have the absolute value isolated, we can interpret what that means. We want values whose distance from 0 is less than 10. So that will mean that when we evaluate 3x plus 5, we're getting values that are between negative 10 and positive 10. So we've really got negative 10 less than or equal to 3x plus 5 less than or equal to positive 10. Subtract 5 from both sides, negative 15 is less than or equal to 3x is less than or equal to 5. Divide by 3, negative 5 is less than or equal to x is less than or equal to 5/3. So in interval notation, since we're including these endpoints because x can be negative 5 or x can be 5/3, then it's going to be all values from negative 5 to 5/3 in square brackets.